Welcome back once again to this tutorial. Please, someone asked a question in our comments when we uploaded the first video, which is sine of cos inverse of x all power 2. When we have equation of this sort, how do we differentiate them? To do that, we said y equals sine cos inverse of x all power 2 can also be written as sine square cos inverse of x. Good. So with this, to solve this straightforward, it will look a little bit complex. So we can make cos inverse of x as u. So let u equals cos inverse of x. So we said whenever we have d dx, cos inverse of any function u is just the same as finding the derivative of u divided by square root of 1 minus u squared. Then we negate it, as the sine inverse will rather be the positive of the same function here, which is u prime over square root of 1 minus u squared. Okay, so let's go with cos inverse of x. So that's du dx will now be minus, differentiate x, will get 1 divided by square root of 1 minus the x squared. So that's the derivative of u over here. So let's come back to our y. We said let u be cos inverse of x. So wherever we see cos inverse of x, we just substitute u there. So that will give us y equals sine square u. Good. So having this, it can also be written as sine u all square. So now let's differentiate y, which is y equals sine u all square. So let's differentiate this, which will give us dy on du, as we have in terms of u here, we are differentiating in terms of the u. So that will give us, differentiate this as just one function, that will give us 2 sine u, then we differentiate whatsoever is in the bracket, which will give us cos u. Cos u. Good. So from here, let's come back. We want to find dy dx, where y is sine squared cos inverse of x. So let's say dy on dx will be equal to, by chain rule, we can say dy dx. We want to write it in terms of u as well. So that will be dy over du times du over dx. So that when du goes with du, we'll still have dy over dx. So now let's go. We have dy du here. So whenever I say dy du, just substitute the value over here, which is 2 sine u cos u, multiplying du dx, which we have here to be du dx to be minus 1 over 1 minus x squared. So that will be minus 1 over square root of 1 minus x squared, which we can rewrite as minus 2 sine u cos u all divided by square root of 1 minus x squared. Okay. So having this, let's come back to our u here. We said u is the same as cos inverse of u, cos inverse of x. So that means I can rewrite this as cos u equals x. Let's rewrite this in terms of right angle triangle here. As we said, cos u, which can be written as x, which is x on 1. So now let's come here. Meaning our angle here is now u. So which is here u. Cos u, that means adjacent over hypotenuse. And the adjacent here will now be our x. The hypotenuse here is 1. So with Pythagoras theorem, which is 1 square equals x squared plus the opposite here squared, that will give us the opposite over here to just be square root of 1 minus x squared. Square root of 1 minus x squared. So from that, let's come back to our du dx. We said dy on dx equals whatsoever function we have, which we have sine u here. Now let's come sine u. Since this is our u represented here, sine is opposite over the hypotenuse. So sine u. So that will be opposite over the hypotenuse. So 2 minus 2 sine u, which is square root of opposite, which is 1 minus x squared, divided by the hypotenuse 1, which will give us the same function, times cos u, which we have cos u over there to be what? Cos u over here, which gives us just x. So wherever we see cos u, just substitute x there, divided by, let's get back here, we have square root of 1 minus x squared, which is represented there. Square root of 1 minus x squared. So from here we can see that square root of 1 minus x squared will cancel out this square root of 1 minus x squared. So that will give us just minus 2x as our final solution. So that's the solution for this. Thank you for watching this tutorial.